Hey everyone, in today's video, the Tandberg from hell is back. Last year this thing showed up on my bench and it was not working, and after breaking it even more and causing a lot of problems for myself, I did fix it. But what I didn't tell you is that I used this with my main system with my magnepans, and now it's back up here. What's wrong with it? I'll show you. So just a quick refresher on this thing. This is a Tandberg 3026A. It is rated at 150 watts per channel into 8 ohms. And this is a pretty nice power amplifier. It drives my Magnepan MG3.6Rs very nicely. Very simple in the back. You got your inputs on the outsides and then your outputs on the inside right there. So here's the very first problem I'm having with this thing. You may recall I replaced this power switch when I got this amp. You may notice that it is turned off, and you may notice that this is turned off. But when I switch this to line voltage, you see, this thing likes to draw a lot of current, big inrush current on this thing. But why is it doing that when the power switch is turned off? For whatever reason, this switch has already failed, so we will need to replace it with a new one. And for me, if I'm going to be running this amp daily in my system, I'm going to want all the capacitors replaced because, you know, I can. It's not going to be very high cost to me, and it's going to drastically improve the reliability of this amplifier. And even though the filter caps tested fine when I was doing my repair, I bought new ones anyways. It's going to be pretty interesting getting those to fit, and I don't know what's going to happen just yet, so stay tuned for that. So this thing has really interesting yet simple construction. First thing you got to do is use a 2mm Allen key. And you're going to loosen these two set screws right here. And you're going to take out these two Phillips head screws. First comes this piece, then this piece slides out and comes up. Two more screws are exposed. And then you just lift this right off. I'll go ahead and take my old load resistor and carefully discharge these guys. And there's better ways to discharge a capacitor than that. There's tools people make, but that's been working just fine for me. So if you look closely, you can look for the purple capacitors on the power supply board, and that would be where I've been. But a lot of them are still original. And if I'm going to run this amp as my daily driver, I want it to be reliable. So I'm gonna go through and recap this thing, obviously replace that power switch, and now you can see what I was talking about with these filter caps here. These new ones have screw terminals, but these old ones, they're just solder lugs coming through this circuit board. I'm thinking I might be able to get away with drilling some holes and then using the screws that come with this. Maybe. We'll find out. Of course, something learned late, way too late in the first video. There's an access panel under here that you can undo so that you can service this thing easily. Lift up, and there it is. I like to do my desoldering upright, kind of like this, and then I can take my Heiko, just get right in here, and then look over here and grab the necessary components. I'm also paying attention to the transformer on this thing. I want the center of gravity of this thing to be as low as possible, so if I do stuff like this or bump it, the chances of it falling are less. This doesn't really matter too much for a unit that has its transformer in the very center, but for, you know, most average Pioneer stereo receivers, for example, they put it in the back corner. You're going to want to pay attention to that when you're doing stuff like this. So I'm going to start with the power supply, and half of the caps have already been replaced. A lot of those were 47 microfarad 100 volt and 10 microfarad 100 volt. I'm going to replace the rest, but I want to talk about something real quick with capacitors. You haven't seen these guys in a little while. These are Panasonic FC series capacitors, and I thought these were discontinued for the longest time. When I restored my very first Marantz receiver back in 2014, this one right here, I bought a rebuild kit, and that kit came with Panasonic FC series capacitors, which were good for power supplies. If we look at the power supply here, the FC series capacitors are denoted by the blue color with the gold stripe for the negative. You can also see them here on one of the FM boards. Blue with a gold stripe. But sometime shortly after that, it appeared Panasonic stopped making the FC series capacitor, which was really liked by a lot of people on Audio Karma, so a lot of us switched to the Nichicon PW. And then in the last 3 years, I've noticed Nichicon beginning to phase out different values of PW series capacitors that are commonly used in these receivers. I was getting kind of worried. I did a last time buy on a lot of them, so I've got a irresponsible amount of capacitors on me. I did the same thing for the ES series, the green bipolar ones. I've been getting a little nervous about capacitors for these things, so it made me really happy when I went to search for some of the 100-volt capacitors for this Tandberg, that the Panasonic FC series capacitor came up as a replacement. So there is some hope, but you know, it's still kind of a weird reality of modern electronics. The electrolytic capacitor is not being used like it once was when consumer electronics were like this. You know, your Amazon Echo or whatever thingy is not going to use this many electrolytic capacitors. Maybe it's got one or two for a DC power supply, but beyond that, you know, the electronics manufacturers are going to make components for customers who are making new designs and new products. They don't just make KSA 992 transistors for us. You know, a 992 or an 1845 is going to be used in a modern design. That's why they make it. We are so insignificant in terms of electronic component manufacturers' profits, the hobbyists. We are nothing to them. So, I don't know. It's just one of those realities, you know, as we move through this. You know, I've only been involved with this a little over 10 years now. I've thought about making a video on this subject and basically just saying what I just said, but one, I don't think it would do that well, and two, I think there's other people who'd do a better job making that video than I would. So there's a free idea for you, anybody who's watching that's also in this space. If you want to search them on Mouser, you just type in EEU-FC, and that should, in a search, populate all available FC series capacitors. And this is the obnoxious part. Like, I literally am just looking for a cap in here. Like, I see the big one, and I think I see it right here. So I'm going to go for this joint, and this joint, and there. That's one cap removed. And that's the name of the game here, so I'm going to go ahead and do that. So there's that, and of course you saw me doing them one at a time, making sure I get the orientation correctly, you know, paying attention to how it's in my hand when I remove it, saying things like, you know, negative down. Like if I say negative down the whole time, then, you know, this negative thing is down, so then when I go to put the new one in, its negative leg is down, you know. Little things you can say to yourself to help out. So now we can get to soldering this board. We'll flip it fully upside down again. Now I'm a little annoyed. These boards have really junky traces, like they lift super easily, and I was having a lot of trouble last time with that. Yeah, right there, that trace got lifted. So luckily it goes to a pretty hefty ground plane over there. So I think what I'll do is I'll solder that one in place and then just kind of solder this one also, but then just take the rest of this lead and kind of bend it such that it can go into that, and then we'll have a nice reliable connection there. Not a proper fix per se, but I do this kind of crap all the time and it's never come back and haunted me. So yeah, look at this guy right here. There's that. I think I'll take these tweezers, bend this down, and I can try and twist this right here to kind of follow that actual trace. I'll cut it right here, and I'll be able to, one, finish this, and two, get this in here and solder to this nice thick ground thing here, or whatever. Sorry, I needed to be able to see for that, but there's the end result. Snip that with these guys here. Everything else turned out fine. No other lifted traces, so I'll go through and wrap up soldering these. you may notice I've left these two. Well, that's because these are the big ones that I want to make sure they sit perfectly straight in the amplifier. I don't want them to look bad. So I'm just taking my finger, straightening it out, and then bending the leads a little bit more strongly such that it's not going to move around when I take my finger off. I know it stands straight. Now I can go ahead and solder those too. Alright, so we've got the power supply recapped. Let's go power this thing on the dim bulb and make sure that we've done everything correctly. And I'm switching to a 200 watt bulb because this amp draws a lot of current, and that little 95 watt bulb, it pretty much lights up bright when you're using that one. So we're turned off. Let's go to dim bulb, and that's pretty good right there. Is anything gonna pop, bang, or explode, or are we going to get a relay click? There's our relay click. If I missed a polarity on a capacitor, we would know by now. It would have released the magic smoke. So this is a great thing. So I'll go ahead and turn this off, and we can move on to one of the amp boards. Probably both of the amp boards. Alright, it's the same story for each amp board. I'm just gonna recap them and come back when I'm done. Let's turn the dim bulb back on. If we get a relay click and no smoke, we should be okay. Wait for it. Perfect. I will double check the DC offset real quick. Let's just set this to DC, make sure there's nothing insane happening, which there really shouldn't be because got the relay click, which would unclick if there were bad DC offsets. So left channel, 30 millivolts, that's fine. Right channel, that's a little high. We'll have to adjust that later. But yeah, looking good. So I wanted to replace the mica insulators and the thermal compound for the output transistors, and unfortunately I don't think I'm going to. And I'll tell you why. You see, the way Tandberg did this is they used like a little terminal thing that kind of slips over the pin of the output transistor, but then they soldered it in place. And in order to get that off, you need to hold the iron to this terminal, pull on it with a pair of pliers, try not to melt the insulator there, and then you can remove your output transistor. And then to put it back on, you have that old solder left over. In fact, I'll show you. I know this because I already got one of them off, and it was a pretty unpleasant experience. I just held the iron on this and then pulled with the pliers, and I'm just a little uncomfortable doing that 16 times. And now that I've got this off, to put it back on, well, it doesn't just slide back on, I've got to use the iron to put this back on also. I feel like I'm going to risk breaking off one of the pins on one of these transistors, and if that happens, I don't know where to get them. These are special. I think they are FETs, not BJTs. I do have this one loose here, right? And I could get this all the way out if I undid that other one. But I'm looking in here and the thermal compound is not dried up. It's still plenty greasy. If the thermal compound was not working, there'd probably be concentrated heat here or problems, but this whole thing gets plenty warm. I don't like it, but I think the thermal compound continues to do its job. Since I've got these screws loose, if anything, I could maybe sneak a little bit of Dow 340 in there just to get fresh stuff in there. But I don't think that's going to benefit anything, honestly. This would be a good one for the thermal camera. If I had a thermal camera, I could take an image of a transistor that has the thermal compound replaced and one that does not. That'd be pretty interesting. I actually did buy a thermal camera at one point. I bought the FLIR 1 smartphone thermal camera, and I thought it was absolute garbage. Like, the way it would create the images is it would put like an outline around what was, like, you know, actually in the image, what you were actually looking at. But then the hot parts of the image, or like where it would color it for different thermal characteristics, like that was just not at all in line with the image. I think I have a photo I can put in here. Like it just wasn't doing it. And yeah, there was an adjustment for that. You could adjust it manually, which in 2026 is insane to me. Like, any half decent piece of technology that's doing that should be able to adjust itself and center itself. That's just my opinion, but yeah, I returned it. So I think I'll get one of those top-down ones that Spare Time Repair used. That one looked to be pretty nice. So right here, I'm gonna try and slip this back on. We'll grab the iron and the pliers, and hopefully I can film this. I'm just gonna bring it on like right there. We'll heat it, and then hopefully we'll be able to slide easily. There we go. Yep, that's it. That's just uncomfortable. That made me uncomfortable, so we're just gonna leave the outputs alone, as disappointed as I am. But that brings us to our next capacitors, these two green guys here. We get to those by removing this board, and this board has a bunch of wires going to it. And we're just gonna have to see what happens when we remove these screws. Looks like we'll have a bunch of standoffs fall off with them, which will just be so lovely to put back together. I might just back these all out as far as I can, and then just push the board out. Maybe I can just sneak the iron in there and try and desolder that way. Same thing all over again, just for two little capacitors. Alright, success. Let's confirm that real quick, shall we? I think everything's put back. Yep, that looks good. If we get the relay click, we'll be super good. This one always takes a while. Yep, not bad. I mean, I'm still pretty disappointed about the output transistor thing. Like, I really want to get the thermal compound replaced on that, but like I would do it if one of them were blown or something. But again, the thermal compound feels fine. It's still greasy. It's not dried up. I think it's going to be okay. Beyond that, we got two things left. We've got the power switch, and we have the filter capacitors. Power switch will be nothing to get taken care of, so we can do that real quick. And that'll be easy. We just unplug these quick connects right here. It clips right into the panel, so we should be able to kind of push on one of the locking tabs with the screwdriver, or both of them. Then just this one underneath too. Yep, got it with my fingers. So here's our new one. It's exactly the same. I'm hoping that that one was just defective and we don't have the same problem again. So we'll just snap that right into the panel, like so. And then I guess I'll use the other pole for this one. Try that side of it. And if I have trouble, I'll go back to the other side, I guess. And I don't think we're about to get an easy repair with these filter capacitors. The idea is we want to maintain this circuit board, but try to get them to work with these screw terminals. So the first thing we have to do for that is we're going to crank up the Heiko all the way. Get it nice and really hot. And that's going to allow us to melt all this solder. and we'll probably be able to lift this board up and get those capacitors out of there. So let's see what happens when I put it on this. So now she's loose. Looks like we still got some trouble over here. So we'll heat that. And there it is. I think we can start just disconnecting these guys. So here's our new replacement, this Nichicon. I hope 22,000 isn't too many. You know, you don't want too big of an inrush current when you turn this thing on. I think it'll be fine just based on what's happened in the past, but the biggest difference is going to be the screw terminal. So what that means is when we put this in here, and by the way, it came with these brackets, so I don't even have to swap the brackets, which is really nice. I'm thinking we drill a hole in this board and then just use the screws that came with it. So the first thing we have to do is measure center to center on these terminals here. Let's do this in metric, since this is a Norwegian amplifier with parts made out of Japan. Center to center on this guy, we can kind of start from edge to edge right here. And I'm pretty good at eyeballing with the caliper. So just eyeballing this and looking for a whole number that is 20 millimeters. Then over here, I think it's going to be a little bit wider. And then on this one, it is 22 millimeters. So we've got a 2 millimeter difference, which means that at the center of each solder hole over here, we're going to have to bump it out 1 millimeter. And this right here is one of my most toxic traits, folks. I would rather put a block of wood in here for support and drill with this in the unit than undo these bolts, take the board out, drill it that way, and then put it back in. This is what I would rather do. What this means here is I need to figure out where the centers of each of these holes are, and then try to bump it out 1 millimeter and then just kind of mark it. It'd be nice if it was 20, because then I could just drill in the center of each of these slits, but now I gotta make sure I add a 1 millimeter offset for each one. And just kind of mark that the best I can. And with that, I can give it a go with the hand drill and see what happens. I think I'll need to get the vacuum cleaner to clean up that dust. Yeah, I think that'll work. Seems to be leaving enough metal left intact. Alright, so what I've done here is I've loosened the bracket. Bracket came installed from the factory, so now I can rotate this because, you know, the bracket needs to go on the chassis a certain way and the cap needs to be clocked a certain way. So let's get these in. I'm not going to tighten any of them just yet. We have 4 holes that are lined up. And we can put those screws in and do a little test fit. And I'm going to add these washers here because they're going to kind of grip into the metal on that board a little bit better than this flat washer will. I'm going to clean all the flux and stuff off of this and probably just add a nice new layer of solder, just to make dang sure everything's going to be okay. This will be another great application for the thermal camera. If any one of these screws are getting hot, that would imply that you don't have a very good connection. I like this. This looks pretty good. I'll be able to clock this correctly when I do a final tighten down. I'm going to take this Sharpie and I'm going to draw a line on each one so that I know where to tighten the bracket. and then this will be ready for final assembly. Do a new line for this one because I had it backwards. That would have been bad. You don't want the polarity backwards on these guys, that's for sure. I'm probably way overthinking this, but I would like to try to solder the rugged, the kind of toothy-like washer onto the board. See if I can get that to be kind of stationary, and then that's interfacing with this washer. You can still get the thing apart. Just try to get that washer onto the circuit board. Let's see. And yeah, see, that thing is one with the board now, so I like it. I think this is going to be great. And yeah, a number of you commented on this thing's video and said if you put your bulb there, you're going to break it. And I was like, no, it's going to be fine. And then, of course, off camera I was manipulating this thing and I did bump the bulb. Didn't break it, but I bumped it, and that's enough for me to... This is what I used to use. You might remember this from really early videos. I had that plugged right into the dim bulb, but now we're plugged in right here. Anyways, let's go ahead and plug this thing back in and run the dim bulb and see if it works. Oh, that's right. I replaced the power switch, so I need to turn the unit on first. Okay. Alright, that looks good. That looks real good. Look at that sweet, sweet relay click. Yes, we do. All the components are replaced. All the caps are replaced. There's not a single old cap in here minus the minus the film ones that were loose in the original video. You may remember that. But those are lifetime caps. They don't need to be changed. They're good ones. So now it's time to clean up this mess and go through the audio adjustment procedure. Getting to the point where I'm honestly a little bit uncomfortable because the last time I tried adjusting this amplifier, I ended up blowing it up, and that basically turned into the entire video. I don't want to do that again, so I'm going to need to be very careful. Without further ado, let's get this thing warming up. Man, the inrush current on this thing is intense. That dimmed the lights, and you probably saw that amp meter go wild. Alright, now it's time to do the amplifier's adjustment procedure, and very unfortunately we're not able to do this amplifier's adjustment procedure at this bench because this bench does not have a distortion meter. There are steps outlined in the alignment procedure on how to use a distortion meter to set certain potentiometers in here and get certain desired results. Long ago, when this was first on the channel, the left channel was working okay, but the right channel suffered some major damage from this guy. So we just assumed that the left channel was okay. We made the right channel match the left, and everything worked out okay. but we can still check the simple things like the DC offset and the bias. So we'll start with the DC offset. For that, we'll use the voltmeter. Set the DC, we'll put our black probe on negative for the filter caps here, which is common with the chassis ground or negative speaker terminal. And then we'll take this, we'll clip it onto the right. And we see that on the right channel, we've got pretty good DC offset. And I watched the old video back, and this kind of weird little bit of drifting it does is normal. That's what it did last time. It'll go up to like -40, it might go up to 40, you know? It's kind of weird what this thing does with DC offset, but as far as I'm concerned, that's okay. And service manual just says if you're within ±50, you're set. So let's check the left channel now. And at the left, we have the same situation. Very similar. So I am not going to adjust that. We're going to call that good, because I adjusted it last time. Now we get to check the bias. And the bias is pretty freaking easy on this amp. All you do is go over to this board over here, and you measure across these two terminals right here. So we'll clip on to one. And then we'll clip on to the other. We are supposed to have 30 millivolts. We've got 27. That is just fine by me. This amp runs hot. It gets very hot. And we're just going to leave it at, well, 28, 27. Yep, whatever. So now let's go to the other side. Left channel, same thing. We're going to grab those two terminals. Or test points, rather. There's one. There's the other. Oh, would you look at that? They're absolutely identical. Even more reason not to mess with it. I like that. Alright, it's time to test for power. And yeah, I would be using my new scope to get an actual voltage reading down there, but I can't figure out how to get this thing to show up in there. The signal is too powerful. It just stops reading it and it goes off the screen every time I get above clipping, because we got ourselves a real powerful power amplifier here. But this guy is no problem. So what we're going to do is we're going to take a look at the left channel first. So we'll set it to channel 1. We've got the sine wave coming through here. We'll read the volts with this guy. We'll zoom in for funsies. And of course the power wash 2245 is just working as a preamplifier right now. Let's crank this up. We're going to look for clipping, see what voltage we get here. So we go up to there. There's our clipping. Pull back until it's gone. It appears to be symmetric. So right about there, I'd call that 38 volts AC. And folks, that's pretty cool, because if you look back at the old video, it actually showed 36.8. So today, for whatever reason, it could be the new filter capacitors, maybe, this thing is running more powerfully than it did before. So let's get our position right on there. Let's try the right channel, see if we've got the same 38 volts. So about right there. Yeah, exactly the same. Yeah, that comes out to a very solid 180 watts per channel. Let's switch this thing to the speakers, and let's play everybody's favorite song. Oh, might want to turn the tone off. My bad. There we go. And that sounds really good. And then yeah, how hot are these things? This thing is warm, but it's not like burning my hand or anything. That's a big concern I have with the new box, is putting the resistors in there like that. I'm not thrilled with it, especially when you get to something of this power. Like if I ever get that Carver M1.5T going again, Probably not going to do a full power test with that box. Probably going to have to move the resistors outside of that because that is a lot of heat. But we'll see if that day ever comes. Anyways, now we've got a fully restored Tandberg 3026A. I didn't do this the first time because I thought this was just going to be repair and go back to the customer. But as it turns out, I felt a little self-conscious about the shoddy repair I did the first time and how hard of a time it gave me. So I wanted to give it a good test, and I tested it with my Magnepan MG3.6Rs, and I noticed a big difference in sound versus the Carver M200T I was driving them with. So I reached out to the guy, I said, can I buy this off of you? And I don't normally do that, I don't like to do that. I felt bad to it, I still feel bad, even though I shouldn't. He agreed to a deal. But yeah, that's how I got this, and I've been using it like that ever since. So I'm happy to have this thing, you know, fully restored. Like, I feel like I can really fully trust this now. You know, the extra power bump up to 180 watts is something I'm certainly not complaining about. It would make some sense that that is due to the new filter capacitors. They're 22,000 microfarad instead of 15,000. The old ones, one of them was measuring around 14.5, the other one's 16, so they weren't exactly even anymore. I didn't do power testing before and after the replacement of each component, so I really couldn't tell you what exactly it is that made this thing more powerful, but let's just say, for funsies, that it was those component replacements that did it. But it is definitely fun to speculate what made this thing make more power, right? I do wish we could give this thing the full adjustment as stated in the service manual with the distortion meter, but that's just not how this setup is current state. If there's ever a distortion meter in here, this will be one of the first things I use it on. But until then, I still believe strongly in, you know, if you're doing this as a hobby and you're just having fun, if it's not running hot and it sounds good, what more do you want? You know, if you like the way it sounds and it's not running hot, which would mean something is wrong, then this is fine. I have no problem with this thing going the way it is. I like the way it sounds with my Magnepans. I play it very loudly, and it's great. So with that, thank you so much for watching. I guess we can once again open up the never-ending debate of restore or not restore, replace all caps, not replace all caps. This thing worked just fine with all the original caps. Everything I pulled had maybe a little bit higher ESR than what was going in new, so none of them were terribly bad or out of spec. But you know, like I say in my restoration guide videos, you do this for reliability. And when you're me and you can do this and it's your stuff, I go ahead and do it, because I'll tell you what, the Marantz 2250B that this channel got started with, I haven't touched it. It's been in the system being used most days for the last 5 years. I haven't touched it. It hasn't needed anything because it got everything. So that's a testament to restoration and increased reliability. It's been a great unit. Haven't even had to clean switches. Let me know what you think of that in the comments. Thank you to my subscribers, and thank you to my members who get early access to videos just like this one. I will see you in the next one.